In this video, we'll be talking about constraints that you can place on your columns. This would be a topic that we'll come back to. I mean, almost all of the theory in this class has to do with keys and other sorts of constraints. But for now, what we're going to talk about are things that you can do in order to limit the ability for you to add bad data or to change your database in a way that you have bad data inside your database. All right, the first and most common constraint that you would place on a column is that of making the column unique. So a unique column is a column whose values have to be unique for every row, that you're not allowed to have any duplicate, any repetition. How do you specify that? You specify it in the create table statement. So here's a create table statement for students. And what we might say is, okay, well, I'm trying to store information from the class. I have your MSU ID, I have your hacker rank, and I have your first name. Now, all of those columns should be text. They're all strings. But no student in my class should have the same MSU ID as some other student. And no student in my class should have the same hacker rank username as another student. However, students can have the same first names if that happens to be the case. They don't all have to be unique. And why do you put these constraints? You put these constraints so that your database management software will raise an error if you try to perform a query that would violate that constraint. Like if you try to insert a row into your database that doesn't maintain this unique property. Okay? So given that we've talked about unique, one thing you might want to think about is, well, how do nulls get affected by this? So the first multiple choice question is a little tricky, but try to think it through. Should nulls be allowed in a unique column? And so from first principles, it's actually a really tricky question. Should you allow nulls to be in a unique column? And I would imagine that really any of these answers could be correct, but there's only actually one specified by the SQL standard, and that is actually the one that's probably the least makes sense to you, and that's 3 here, as many as desired. You can have as many null values in a unique column as you want, because every unknown value is unique from every other unknown value. So you are allowed to have nulls in a unique column. It may seem hard to keep your head around. In reality, usually you try to remove as many places where there might be nulls as possible. But if you have unknown data, who's to say whether or not that unknown data is different from other unknown data or other data that's in your database? So the correct answer here is, are nulls allowed in unique columns? The answer is yes. You can have 1 or 0 or 100 nulls in a unique column. So how do you tell that a column should not be allowed to contain nulls? Well, you use the not null constraint. Really tricky here. So what does that look like? It looks like MSU ID text unique, not null. So this is a column that has to be unique and not null. So if I don't have your guys' MSU ID, I can't add you to this database. You can also specify that something is not null but not necessarily unique. So for instance, which section you are in this class. All of you guys may not even have a section assigned. You guys all may, all of you guys must have a section assigned, but you guys don't all have to have a unique section assigned. So all of you guys can be in section 1, or some of you guys can be in section 1 and some of you in section 2. The rule here is you're not allowed to have null data here, so I need to have a number specified for all of your guys' sections. And like the unique thing, it means that your database management system will enforce that if you try to add a null to this column, it won't succeed. It will raise an error. It will let you know that something is wrong. All right. The next thing is actually kind of a combination of the previous two, and it's what's called the primary key. And once again, this is something that we'll be coming back to later on in the course. And each table can have at most one primary key column. And it's implicitly not null and unique. You don't need to say that the primary key is not null and unique. It's already assumed. Like that's how primary keys must work. And so it's used to specify one specific row in a table. You can't have more than one primary key in a table. And the way that you specify it looks like this. You would say, hey, one of the columns, MSU ID in this case, is a textual column, and it's the primary key for the table. And you can have other columns, but they can't be primary keys. And why do you use the primary key? Well, we'll come back to this. The reason why you often have a primary key is so that you can use it to join two tables together, which would be the subject of the next video. The other thing to note is that you're allowed to have composite primary keys. These are primary keys that are built out of multiple columns. Like say, for instance, we have two columns in our table, first name and last name. Neither of those columns is unique, because you can have multiple people in the class with the same first name, you can have multiple people in the class with the same last name, but let's pretend that there is a rule at the university that they're not allowed to ever have two students with the same first and last name. So how do you specify that you have a primary key that's the combination of these two columns? Well, you basically add kind of a pseudo column to your table. So you have your first name column, you have your last name column, and then you have your primary key, which is built out of the combination of a first name and a last name. And so why do we use primary keys? The primary reason is you can join two relations that both have primary keys together more easily than by specifying particular columns that link up these two tables. Once again, we'll come back to this in a bit. They also indicate to the database, hey, I'm often going to be caring about this primary key row. It might be a good idea to sort the rows or to organize the table according to primary key. Once again, this is a sort of optimization we'll be coming back to. And so if you specify to the database, hey, this is a primary key column, you can actually get faster queries. And so the best practice when working with tables is usually that every table should have some primary key. So multiple choice question here. Which of these columns, so imagine these are all columns in some database, would be the best candidate for the primary key? So in reality, all of these might make good primary keys. It depends really on a lot of the other tables in your database that you might be trying to combine this table with. Really, once again, the only rule for a primary key is it must be unique and not null. So if I knew everybody's social security number and I knew nobody could have the same social security number, that would make a good candidate, but the same rules apply to the other three as well. In reality, all of these examples are often used as primary keys, with the exception of usually first and last name doesn't make a good primary key, because in reality, you can have students with the same first and last name. All right. A couple other topics that I want to tack onto the end of this video. One of which is, this will make sense more for the next section when we start talking about joins, is sometimes it's better to use a longer version of a name so that you can be really clear exactly what column and table you're specifying. So a qualified name of a table is a table that you name kind of its full length name. So the full length name of a table is the name of a database dot the name of a relation. So for example, if we have the table named students and the database is named main, this would be main.students. You could also have qualified names for columns, and this is a lot more common. And that is, you have the qualified relation dot name of column. So you can say main.students.msuid, or you can just say students.msuid if it's ever unclear which table the column belongs to. And so sometimes, especially for columns, for qualifying names of tables, we don't really need to do that much in this class. But often it's important to qualify the name of a column because you might have multiple tables that have the same names for columns. And so the way that this looks is, instead of saying select name from students, this means exactly the same thing as select students.name from students. It's just being really clear that this name column belongs to the table students. So you can use this qualified name wherever you like. So for instance, you can use it in the where clause. You can use the qualified name some of the time and use unqualified names as well. The important thing is that when I see that name column, I know it belongs to the table of students, as opposed to having to try to infer that by other means. The last thing I want to talk about is, once again, something that will help make some of the queries we write later in the class a little bit easier to read or easier to understand, is that of aliases. So the way that you make aliases in SQL is to use the as keyword. And this is useful if you want to, for instance, refer to a column by a different name. So what would that look like? So for instance, let's say that I want to select the MSU NetID as ID. MSU NetID is too long for me just to normally type out, even though that's the name of the column from this table. So instead, I'm going to say select MSU NetID as ID. So now, henceforth, whenever I say ID, I really mean like it's a shortcut to MSU NetID from students. And now I can use that shortened version. I can say where ID equals Nahum Joss, as opposed to where MSU _net _ ID equals Nahum Joss. So this is a way to come up with like little shortcuts, little aliases for complicated names, names that are really long to write. Or if you have multiple columns that sound very similar, it's often useful to use an alias to make the names a lot less ambiguous. And you can also use aliases on tables. For instance, I can say select CSE480.MSUNetID from students as CSE480. So I'm saying the table is actually called students, but for in this query, instead of calling it students, I'm going to be calling it CSE480, and I can use that CSE480 in other parts of the clause. One much worse form of aliasing to use is to just say from students space CSE480. There's an implicit as here, but in reality, you really shouldn't ever be writing queries like that because it's very easy to get confused as to what's going on here. The as makes it a lot more obvious that you're trying to rename a column or rename a table for the purpose of this query.